Children, we have studied this algebraic expression and the polynomial in our previous year classes. Now we are going to extend the continuation of these chapters. Now let me take f of x as the polynomial, which is defined like this: an x to the power n plus an minus 1, x to the power n minus 1, etc. a1x plus a0 is said to be a polynomial in the variable x. Now, what is x? X is any variable and n is any positive integer. What about these an minus 1, an minus 2, a1 and a0? These are all any real numbers. Now, we are going to study deeper on this concept polynomial. We can write it as p of x or f of x. Both mean the same. Now, we have studied in our earlier classes about the linear polynomial and power 2 polynomial, power 3 polynomial. These are all the polynomial algebraic expression you must have studied. So, these are the polynomial that we are going to learn little more deeper. Children, we have studied this linear polynomial which takes the form ax plus b as the linear polynomial, where the power of the variable x is just a number 1. Then it is linear polynomial. Now the second one, you have studied the quadratic polynomial. We write it as ax square plus bx plus c, where the highest degree or the degree of the polynomial here is 2. The highest power of the variable is 2. Then we say that it is quadratic polynomial. 2 means it is quadratic polynomial. Now I extend ax cube plus bx square plus cx plus d, where the highest power of this variable is 3. So we say that this is nothing but cubic polynomial, power 3 polynomial. I do extend my polynomial with the power ax power 4 bx cube plus cx squared plus dx plus some variable m or n, the real number which is the constant. Then we say that this is biquadratic polynomial. So the highest power of the variable is 4. Then we say that it is a biquadratic polynomial, power 5 polynomial, power 6 polynomial, etc. The polynomials based on the power, we have different polynomials. Now our concentration in this chapter is mostly on this quadratic polynomial. So ax square bx plus c is the general form of the quadratic polynomial. Now children, what is the constant polynomial? The constant polynomial where the power of the variable is 0. I can tell you the constant polynomial is ax raised to 0, which is the constant polynomial. So how do we say there is ax to the power 0 is nothing but 1. So my polynomial is just a number a, where a is any real number. So I give an example. Any real number is also a polynomial, that we can write it as just a number with the power is 0 of the variable. So any constant polynomial having the power of the variable 0. So any number, we can say that it is also a polynomial. Any real number is also a polynomial. We call it as constant polynomial. Now we move on to the value of the polynomial. Now I have the polynomial such that my polynomial takes p of x is equal to some 3x squared plus 2x plus 5 is my polynomial. Now I go and substitute the value in place of x. Suppose 2. So what is my value of this polynomial, that is 3 into 2 square plus 2 into 2 plus 5. That's equal to 4 3s are 12, 12 plus 4 is 16, 16 plus 5 is 21. So the value of the polynomial at x is equal to 2 is 21. Hope everyone understand how to find the value of the polynomial. So when you change the values for different numbers, of course the value of the polynomial will also change. So hope you understand, based on the variable value, the value of the polynomial will also change. Children, now we move on to the next concept of zero of a polynomial. What do you mean by the zero of a polynomial? Suppose I have the polynomial, that is p of x is equal to some x squared plus 5x plus 6. So this is my quadratic polynomial. Now I want to know whether the value of the polynomial becomes 0. So I put my value, suppose that is minus 2. So I get minus 2 the whole square plus 5 into minus 2 plus 6. So I know this is 4, 4 plus 6 is 10, 10 minus 10, which is equal to 0. Now I can say that minus 2 is a 0 of the polynomial. What do you mean by that? When we substitute the value minus 2 in place of x, I get the polynomial value becomes 0. So I call this minus 2 as the 0 of a polynomial. So it is defined if a number alpha is said to be a 0 of a polynomial p of x if and only if p of alpha is equal to 0. So I say that it is defined alpha as any real number alpha is said to be the 0 of the polynomial if and only if p of alpha is equal to 0. So if you substitute any other value, so I substitute other value, suppose p of plus 2 I substitute for this polynomial itself, I get 2 squared plus 5 into 2 plus 6, which is equal to, this is 10, 10 plus 10 is 20. I'm not getting equal to 0. That means 2 is not a 0 of a polynomial, of this polynomial, not a 0 of this polynomial. So hope you understand this concept. The number which makes that polynomial's value as 0, then that real number is said to be the 0 of the polynomial. Children, now we move on to the graphical representation of these polynomials. We have studied in our previous year classes that is the linear polynomial, the graphical representation is a straight line. So you must have studied that there is a pair of linear equation in 9th standard. 3x plus 2y is equal to 5. It's a linear polynomial in two variables. So when you plot the values of x and y in the graph, we get a straight line that we have studied very clearly. So you will take 2y is equal to 5 minus 3x and y is equal to 5 minus 3x divided by 2 and give x is equal to some 0 value. So what you get, y value you will have it, then like that you can give different values for x to get respective y values, and then by plotting those values in the graph we join those points and we get a straight line for this linear polynomial. Now the question is, what would be the graphical representation for the quadratic polynomial? So we have the quadratic polynomial, we have the zeros of the quadratic polynomial. Now what would be the graphical representation? The graphical representation of a quadratic polynomial will be the parabola. So children, now you can see the shapes of the quadratic polynomial, the graphical representation of the quadratic polynomial. Now, my quadratic polynomial, this takes the form ax square plus bx plus c. Then you get the graphical representation as a parabola. This is called parabola. So this parabola is open upwards. Why? Why? Because a is greater than 0. So we see that the graphical representation after giving the values for x and go and plot it, and we can get the parabola which opens upwards. Now this parabola, when you have the graphical representation of a parabola open downwards, that means a is less than 0. So whenever you get the value of a is lesser than 0, then the graphical representation of the parabola will be open downwards. Hope you understand the difference between the open upwards and the downwards parabola. Now, what are the zeros of the parabola? How do we connect that algebraic explanation with this graphical explanation of this parabola? I told you the parabola which makes the value of x, which makes that quadratic polynomial 0, that is said to be the zeros of a polynomial. Now, the values which lie, the parabola which touches on the x-axis, those values will surely make this polynomial value is equal to 0. So, the parabola wherever it touches on the x-axis, then those values will be the zeros of the parabola by graphical representation. The same way here, whichever the values for x touches the x-axis, and those values will be the zeros of the quadratic polynomial. Now, I'll give you a small understanding. The parabola can be like this and the parabola can be like this. So, this all touches the x-axis, but you will have a parabola which doesn't touch the x-axis, and you will have the parabola which doesn't touch the x-axis. Then we say that for this quadratic polynomial, whatsoever may be the polynomial, those polynomial will never have the zeros. So they are not having zeros when the graphical representation does not touch the x-axis. So even if it touch or it cuts the x-axis, it will have the zeros. But when it doesn't touch the x-axis, then it will not have zeros for that quadratic polynomial. Hope everyone understand this concept. Children, now we move on to the next subtitle, the relationship between the zeros and the coefficients of this quadratic polynomial. Now, I told you about the zeros of the quadratic polynomial. Now, you will have the question, how many zeros a quadratic polynomial can have? Why? Because whichever the number makes the polynomial 0, any real number, then that would be the zero of a polynomial. But so many number possible to make that polynomial to be 0. So we will have that question. But I tell you, in a quadratic polynomial, there would be at the most 2 zeros. Only 2 numbers maximum can make that polynomial 0. No other more than 2 numbers can make that polynomial 0. So you will understand for linear polynomial, there will be only one value of x which makes that equation to be 0. That means only one value means the power is 1, so one value. Here the quadratic polynomial, the power is 2, so 2, at the most 2 zeros. That means for the cubic polynomial, of course exactly, it would be maximum 3 zeros, and the biquadratic, of course it is maximum 4 zeros would be there for biquadratic polynomial. Now, I told you there will be 2 zeros, maximum 2 zeros, at the most 2 zeros for the quadratic polynomial. We define those 2 zeros as alpha and beta. We just give them the names. Now what is this alpha and beta? Suddenly you are bringing up the new term. I'll give you an example. I told you one polynomial which is p of x is equal to some x square plus 5x plus 6. I take that same polynomial and I told you minus 2 it will make this polynomial 0. So what I say that x is equal to minus 2, which makes that polynomial 0. So I can see alpha is equal to minus 2. 1, 0, I got it. And I told you there will be maximum of 2. So what would be the next number? I would get x is equal to minus 3. Also, this will become 0. So, p of minus 3, you just put it. So, I would have minus 3 the whole square plus 5 into minus 3 plus 6. So, 3 3s are 9, 9 plus 6 is 15, this is minus 15, which is equal to 0. So, I would say this as beta is equal to minus 3. So, I got my alpha and I got my beta. These are the two zeros for this quadratic polynomial. If you try to substitute any other value, it will never get 0. Why? Because it has at the most 2 zeros only. So it can have equal zeros and it can have 2 different zeros. That's not a condition, but maximum it will have 2 zeros. It can have 0 zeros. That means the zeros are not possible. That's also I told you, when the polynomial, the parabola doesn't touch the x-axis, then for those polynomial, there is no zeros existing. That means it can be 0, equal zeros means 3 and 3. That means it is only 1. So 0 it can be, 1 it can be, and the maximum 2 it can be. So at the most it has 2 zeros. Now these 2 zeros only we define here alpha and beta. Now, what is the relation between these zeros and the coefficients of the quadratic polynomial? So, let me write my quadratic polynomial first, the standard form. So, the standard form of the quadratic polynomial is ax square, p of x is equal to ax square plus bx plus c. This is the quadratic polynomial. Now, I know the coefficient of x square is. So, coefficient of x square is a and coefficient of x is b, and the constant term, it is not a coefficient, we say it is constant term is c. Now, they are telling the relationship between these coefficients and the zeros. You know that the zeros are nothing but alpha and beta are the zeros. So, what is the relation between this ABC and with alpha and beta? It is defined the sum of the zeros, that is alpha plus beta is equal to minus b by a. So, I say this alpha plus beta is equal to minus b by a, or in a words I can write sum of the zeros is equal to minus of coefficient of x divided by coefficient of x squared. So, in terms, in words, we write like this. And the second relation is the product of the zeros is equal to c by a. What is the second relation? The product of zeros is equal to c is the constant term divided by coefficient of x squared. So that is alpha beta is equal to c by a. These are the two relations between the zeros and the coefficients of quadratic polynomial. So hope everyone understands. Shall we move on to the questions? The question says like this. Find the zeros of the quadratic polynomial x square plus 7x plus 12 and verify the relation between these zeros and coefficients. Now, let me write my polynomial first. P of x is equal to x square plus 7x plus 12. Now, I'm going to verify the relationship. So let me have my A is equal to 1, B is equal to 7, C is equal to 12. Now how do you get A, B, C? You have to compare with the standard form ax square plus bx plus c. So here it is 1, so my A becomes 1 and B becomes 7 and C becomes 12. That's what I have written. Now I have to find the zeros here. Why? Because these are the coefficients. I have to get my zeros. So what do I do for getting zeros? I will concentrate on my constant term 12 and find the factors for 12. 1 12s are, 2 6 are, and then 3 4s are, and then it just getting repeated, that is 6 2s are and 12 1s are. Now my perfect factors are 3 and 4. Why, ma'am? When I add, I should get the middle term. When I multiply, I should get the constant term. We studied in our earlier classes how to find the factors for this polynomial. So I would write, I got 3 and 4. So let me write x plus 3 into x plus 4 are the factors of this polynomial. Children, what do you mean by the factors? When I multiply these two factors, I get the same polynomial. As simple as that. That's what the understanding of finding the factors. Now I have to find the zeros. So what do? Let me have x plus 3 equal to 0. So x is equal to minus 3. And then x plus 4 is equal to 0. And then x is equal to minus 4. Now why are you equating to 0? When I substitute minus 3 in this polynomial value becomes 0. That is p of x becomes 0. So I equate x plus 3 equal to 0. That means x is equal to minus 3. Now what do you mean by x is equal to minus 3? This is alpha and the other one is just nothing but beta. These are my two zeros. Alpha and beta I got it, and I got my coefficients too. So now I'm going to verify the relation between them. So how do I verify it? So let me have my verification here such that my LHS, that is, I know the first verification is alpha plus beta is equal to minus b by a. That's my first verification. I have to find the sum of the zeros will be equal to minus of coefficient of x divided by coefficient of x square. Now alpha is minus 3 and then I take my LHS and then minus 3 minus 4 which is equal to minus 7. Now I have to get the same value for my RHS, that is minus b by a is my RHS minus, what is my b? B is 7 divided by my a is 1 which is equal to minus 7. So I got my LHS is equal to RHS. So the first condition relation is verified. Now we move on to the second relation. So what the second relation says, alpha beta is equal to c by a. So the second relation says alpha beta is equal to c by a. The product of zeros is equal to constant term divided by coefficient of x square. Let me multiply my LHS, which is minus 3 into minus 4 which is equal to just a number 12. And my RHS here is equal to c by a, which is c is 12 and my a is 1 which is again just a number 12. So I got my LHS is equal to RHS. That means my second relation is also verified. So hence the relationship between the zeros and the coefficients are verified. Children, we move on to the second question. It says like this: find the zeros of the quadratic polynomial 6x square minus 3 and verify the relationship. Now, let me have my p of x is equal to 6x square minus 3. Now, children, you must have noted this is in the standard form where the coefficient of x is 0. So can we write this as root 6x the whole square minus root 3 the whole square to find our factors. So this can be written a square minus b square. So a plus b root 6x minus root 3 into root 6x plus root 3. So I got a minus b into a plus b. Now I equate it to 0. Root 6x is equal to root 3. So x is equal to root 3 by root 6. So can we have root 3 by root 6 as 1 by root 2? Why? Because root 6 can be written as root 3 into root 2. Root 3 gets cancelled. So this is my alpha. And my next term is root 6x is equal to minus root 3. So I have, this is minus 1 by root 2. This is my beta. So I got my alpha is equal to 1 by root 2 and my beta is equal to minus 1 by root 2. Let me write my coefficients. A is equal to 6 and B equal to 0 and C equal to minus 3. So now I'm going to find the relationship between the sum of the zeros and the coefficients of the quadratic polynomial. So let me have my relation first. So the first relation says alpha plus beta is equal to minus b by a. So my alpha is 1 by root 2 plus of minus 1 by root 2, which must be equal to minus my b is 0 by a is 6. So this becomes 0. That means 0 equal to 0. So LHS is equal to RHS. It is verified. Now the second relation is alpha beta is equal to C by A. My alpha is 1 by root 2 into minus 1 by root 2, which is equal to my C is minus 3 divided by A is 6. So this becomes 1 by 2, which is equal to, I get cancelled, this becomes again 1 by 2, so minus 1 by 2. So my LHS is equal to RHS, so both the relations are verified for this polynomial. And now we move on to the third question. The same concept for the polynomial 4 root 3x square plus 5x minus 2 root 3. So let me have my polynomial. P of x is equal to 4 root 3x square plus 5x minus 2 root 3. Now let me write my a is equal to 4 root 3 and b is equal to 5 and my c is equal to minus 2 root 3. Let me go and find the factors. You have to be very careful since the irrational numbers are also the part of the coefficients. Now what I would do, I would multiply the coefficient of x squared with the constant term. So I get 4 2s are 8, 8 3s are 24. Now I have to go for the splitting the middle term to find my factors. So start from 124 to 12 and then 3 8s are and then you have 4 6 are and then 6 4s are, it gets repeated. Now I should get the addition is 5. So my factors would be 3 and 8. Why? Because plus 8 minus 3 I would get plus 5 and plus 8 into minus 3 I would get minus 24. So I'm going for splitting the middle term, which I would write it 4 root 3x square plus 8x minus 3x minus 2 root 3, which is I'm grouping the term such that 4 is taken outside with x and I'm left with root 3x plus 2 and here minus root 3 is taken outside, so I would left with root 3x minus plus 2. Why? Because minus is taken outside. Now I'm going to take the common term again. So root 3x plus 2 is taken outside. I'm left with 4x minus root 3. So these are the factors of this polynomial p of x. Now I have to get my zeros. So equating each factors to zeros, I get my 0. So my x is equal to minus 2 by root 3. So which is equal to my alpha. And the another value which is 4x minus root 3 equal to 0. So x is equal to root 3 by 4, which is my beta. So I got my alpha and beta. Now I'm going to verify the relationship between them. The first relation is alpha plus beta is equal to minus b by a. So my LHS, I write it alpha as minus 2 by root 3 and my beta as plus root 3 by 4. You have to do some calculations here. Why? Because the denominators are different. So I would have my LCM as 4 root 3 and minus 8 plus root 3 into root 3 is 3, which is equal to minus 5 by 4. Root 3 is my alpha plus beta. Now I have to get my RHS, which is RHS as minus b by a. That is my b is minus 5 by a is 4 root 3. So I got my RHS is also the same. So LHS is equal to RHS. That means my first relation is verified. Now we move on to the second relation. Alpha beta is equal to C by A. The same way we will check it. So my product of zeros, that is alpha beta, is equal to C by A. This is my second relation I am checking. So the first one LHS. So my alpha is minus 2 by root 3 into my beta as root 3 by 4. Gets cancelled. This gets cancelled. My result is minus 1 by 2. Now I go for my RHS. So my RHS is equal to C by A. So let me have my RHS as, which is C by A. That's equal to my C is minus 2 root 3 divided by my A is 4 root 3. So root 3 gets cancelled. This gets cancelled too. And minus 1 by 2. As simple as that. I got both my LHS is equal to RHS. So both are verified. I got my relations verified. Then we move on to the next question, which says like this. Find the zeros of the quadratic polynomial. P of x is equal to abx square minus of b square minus ac into x minus bc, and verify its relation. That's the question. So now we move on for finding the A, B, C, and of course the zeros. So first here we have to find the zeros. So we first give the importance in finding zeros. So let me go for getting my polynomial in its proper way. So if I can group the term and split it and getting the factors, that would be easier. Let me check. So what I do, abx squared. Now I am going to take minus b squared x plus ac into x minus bc. So this is my polynomial. Now I am going to have my x squared x. This I group it. So b and b is common. So I would take bx outside. I'm left with ax minus b. Now here my c is common. So I will take my c ax minus b. I got my factors. So which implies ax minus b is common. So I'm left with bx plus c. So this is my polynomial p of x. To get my x, I would do ax minus b equal to 0. So x is equal to b by a, which is my alpha. So I got my alpha here. And similarly, bx is equal to minus c. So x is equal to minus c by b, which is my beta. So I got my alpha as well as my beta. Now, I'm going to verify the relation. For that, I need my coefficients. So, A is equal to AB and B is equal to minus of B square minus AC, and my constant term is minus BC. So, I got my coefficients here, my alpha and beta I got it. The first relation I am going to verify. That is alpha plus beta is equal to minus B by A. So, let me have my LHS first. My alpha and beta are B by A minus C by B. Now, I have to take the LCM of this. My LCM is AB, so B square minus AC. This is my LHS, I got it. Now, I have to get my RHS. So, let me have my RHS here such that, so RHS is equal to minus B by A. So, my B is minus of B square minus AC divided by my A is AB. So, minus into minus will become positive. That's equal to B square minus AC divided by AB. I got the same as these two are the same values. So, I would have my LHS is equal to RHS. So, my first relation is verified. And I go for the second relation. So, I want all these values. So, I will go for second relation such that my second relation says like this. Second one, product of zeros is equal to C by A. So, let me have my LHS here. My alpha is B by A. My beta is minus C by B. B gets cancelled, which is equal to minus C by A. So, my RHS, I'm going to have it as C by A. So, my RHS is C by A, which is equal to C is minus BC and divided by AB, and BB again gets cancelled, minus C by A. So, I got both the values equal. That means LHS is equal to RHS. As simple as that. I got it. Hence, the relations are verified. We'll move on to the next question. If alpha and beta are the zeros of x squared minus 5x plus k such that alpha minus beta is equal to 1, find k. Children, in this type of question, the first thing, whatever they are asking in polynomial, you must do the relationship between them. So, you get an idea how to get the solution for the required answer. So, do not worry about what do I do. The first thing you will write, what is the relation between the zeros and the coefficients. Let me have my P of x is equal to, I have x squared minus 5x plus k. So, let me have my A is equal to 1 here, B equal to minus 5 and C is equal to k. I cannot find the zeros here. Why? Because it's constant. K is unknown. So, I cannot go for splitting the middle term or quadratic formula. Nothing can be done. So, I would write only the relation such that alpha plus beta is equal to minus B by A. I know that relation. So, alpha plus beta is equal to minus of minus, that is 5. So, I got my alpha plus beta is 5 and alpha beta is equal to C by A. So, which is equal to K by 1. So, that also I got it. That is alpha beta is equal to K. Now, how do I get my find K? It is given alpha minus beta is equal to 1. Now, when this alpha minus beta is given, I do not have any relation with alpha minus beta, but I do know the relation between alpha plus beta and alpha into beta. Now, you have to think the identities. How can I bring this alpha minus beta in terms of alpha plus beta and alpha beta? What am I going to do is, I'm just squaring on both the sides, which is equal to again 1. I'm not changing any value. Now, you must know this alpha minus beta the whole square can be written as alpha plus beta the whole square minus 4 alpha beta, which is equal to 1. Why? Because when you use the identity, substitute the value, you get this is equal to this one. Now, I know alpha plus beta is 5 square minus 4 into alpha beta is just k, which is equal to 1. That is 25 minus 4k is equal to 1. So minus 4k is equal to minus 24. So minus minus gets cancelled, 4 and this gets cancelled. So k is equal to just a number 6. I got my value for k. We'll move on to the next question. If alpha and beta are the zeros of the polynomial kx squared plus 4x plus 4 such that alpha square plus beta square is equal to 24, find k. Now, what do I do first? I will write my p of x is equal to kx squared plus 4x plus 4. I cannot find the zeros as it is given constant k. So let me have my a is equal to k, b is equal to 4 and c is equal to 4. So alpha plus beta is equal to minus b by a. That's equal to minus 4 by k. Now the next one, alpha beta is equal to c by a. That is 4 by k. So I got both. Now my condition given here is alpha square plus beta square is equal to 24. Now you will know that I have to bring it in terms of alpha plus beta and alpha beta. Now children, you must be knowing alpha plus beta the whole square is equal to alpha square plus beta square plus 2 alpha beta. So I want this one. So you bring it to the other side. This can be written as alpha plus beta the whole square minus 2 alpha beta, which is equal to 24. So alpha plus beta, I got it minus 4 by k the whole square minus 2 into alpha beta is 4 by k, which is equal to 24. Now I will square it. 16 by k square minus 8 by k is equal to 24. Now take the LCM, that is k square. So 16 minus 8k is equal to 24. So I'm going to get the quadratic equation. So I have to find the zeros. How do I get it? So for 16 minus 8k is equal to 24k square. So on bringing to the other side, I would have 8k minus 60 is equal to 0. On simplification, I get 6k square plus 2k minus 4 is equal to 0. Now I have to get my factor. 6 4s are 24. I have to get 2. That is 6 and 4 are the factors. So 6k square plus 6k minus 4k minus 4 equal to 0. So group the terms. I would get 6k outside. So I'm left with k plus 1. Minus 4 is taken outside, k plus 1. So my factors are k plus 1 into 6k minus 4 equal to 0. That means k is equal to minus 1 and 6k is equal to 4. On simplification, 3 and 2, k is equal to 2 by 3. So as simple as that, I got both the values minus 1 and 2 by 3. This question says, if alpha and beta are the zeros of 2x square plus 5x plus k such that alpha square plus beta square plus alpha beta is equal to 21 by 4. Find k. Now, see, the concepts are the same way we apply, but we have to think better. So, I got my p of x and I know my a is equal to 2, b is equal to 5 and c is equal to k. Now, I have to get my alpha plus beta is minus b by a, that is 5 by 2. And my alpha beta is equal to c by a, that is k by 2. I got this. Now, my condition given here is alpha squared plus beta squared plus alpha beta is equal to 21 by 4. Children, I told you at the beginning of these questions to be solved, we have to bring it to substitute this alpha plus beta and alpha beta. Here, of course, alpha beta is given, but alpha plus beta is not given. I have to bring it. How do I bring it? Suppose I rearrange these terms as 2 alpha beta minus alpha beta is equal to 21 by 4. It is satisfied. The equation doesn't get any value changed. I got plus 2 alpha beta minus 1 alpha beta is plus alpha beta. What my aim is, I would write this as alpha plus beta the whole square minus alpha beta, which is equal to 21 by 4. So I got my values just to substitute the whole square minus k by 2, which is equal to 21 by 4. I get 25 by 4 minus, I get the k by 2 is equal to 21 by 4. Now, I am not taking the LCM since I would bring it to the other side. Minus k by 2 is equal to 21 minus 25 divided by 4, which is equal to minus 4 by 4 gets cancelled, minus 1, which is minus k is equal to minus 2. So this implies k is equal to 2. So I got the value for k. So as simple as that. Children, now we are moving to the next concept. It says when we are given the zeros, suppose alpha and beta are the zeros of the polynomial, then we have to write the polynomial. How to write the polynomial? We do not know the polynomial, but it is given alpha and beta are the zeros of the polynomial. Then how to get the polynomial? So I would write a polynomial p of x is equal to ax squared plus bx plus c. Then I understood alpha and beta are the zeros of the polynomial. So x minus alpha and x minus beta are the factors of the polynomial p of x. Now, how can I write this in terms of the factors? I can write k into x minus alpha into x minus beta. But how this can be expressed as the coefficient such that x squared minus of alpha plus beta into x plus alpha beta. So the same quadratic polynomial ax squared plus bx plus c can be written in this form where k is any constant, it can be any number. But most of the students get a bit confused of this k. So it can be any number which would be multiplied. So I always tell them you would just have in memory, that is alpha plus beta into x plus alpha beta. X squared minus of alpha plus beta into x plus alpha beta. So the polynomial can be written when your alpha and beta are the zeros given, then using this information, you can get your polynomial. So when alpha and beta are given, you will find alpha plus beta, you will find alpha beta, just substitute in this frame, in this standard form, you get your polynomial. Shall we move on doing the questions based on this concept? If alpha and beta are the zeros of the quadratic polynomial, x square minus x minus 2, find the polynomial whose zeros are 2 alpha plus 1, 2 beta plus 1. Now, what I told you, first you will write your p of x is equal to x square minus x minus 2. Now, we find the factors for this. Why? Because that is possible. So, splitting the middle term, so minus 2x plus x minus 2. So, grouping the terms, x into x minus 2 plus x minus 2. So, my factors are x minus 2 into x plus 1. So, x is equal to 2, which is nothing but my alpha, and x is equal to minus 1, which is nothing but my beta. I got my alpha and beta for this polynomial, but I have to get the polynomial for which these two are the zeros. So let me find my first zeros, that is sum and the product. So 2 alpha plus 1 plus 2 beta plus 1, which is equal to, I get it, 2 alpha plus 2 beta plus 2. So I take my 2 outside, alpha plus beta plus 1. So my 2 into alpha is 2 plus beta is minus 1 plus 1. Minus 1 plus 1 gets cancelled. So my sum is equal to 4. And my product is, so 2 alpha plus 1 into 2 beta plus 1. I have to find the product first. So P is equal to 2 alpha plus 1 into 2 beta plus 1. Let me multiply, that is 4 alpha beta plus 2 alpha plus 2 beta plus 1. So I go and substitute my values. 4 into alpha is 2 into beta is minus 1 plus 2 into alpha is 2 here, and plus 2 into beta is minus 1 here plus 1. So I get my product as, on simplification, minus 8 plus 4 minus 2 plus 1, that's equal to, plus 4 minus 2 is 2, 2 plus 1 is 3, 3 minus 8 is minus 5. I got my product as minus 5. Now I have to get the polynomial. So the polynomial takes the form, polynomial is equal to, that quadratic polynomial is equal to x square minus of sum of the zeros into x plus product of the zeros. So x square minus, my sum of the zeros is 4x plus the product of the zero is minus 5. So my quadratic polynomial is minus 4x minus 5. As simple as that, I got my quadratic polynomial for these two zeros. Shall we move on to the next question? If alpha and beta are the zeros of the quadratic polynomial, 3x square minus 4x plus 1, find a polynomial whose zeros are alpha square by beta and beta square by alpha. Now, p of x is equal to 3x square minus 4x plus 1. So, since the polynomial is in standard form, I can find my zeros, that is 3x square minus 3x minus 1x plus 1. Grouping the term, I get a 3x outside, so x minus 1. Minus is taken outside, x minus 1. So my alpha is equal to 1 and my beta is equal to 1 by 3. I got my alpha and beta for this polynomial. Now I have to get my polynomial such that these are the zeros of that polynomial. Let me find the sum first. So s is equal to alpha square by beta plus beta square by alpha. So let me go and get my sum on simplification. S is equal to alpha cube plus beta cube divided by alpha beta. Now I can write in terms of alpha plus beta and alpha beta, as this can be written as alpha plus beta the whole cube minus 3 alpha beta into alpha plus beta divided by alpha beta. This is using the identity. So I have to get my alpha plus beta and alpha beta. Let me have my alpha plus beta from here. So I have my alpha plus beta is equal to 1 plus 1 by 3, which is equal to 4 by 3, and alpha beta is equal to 1 by 3. So I got my both the values. So go and substitute here, which implies my sum is equal to 4 by 3 the whole cube minus 3 into 1 by 3 into alpha plus beta is again 4 by 3 divided by alpha beta is 1 by 3. 3 gets cancelled. So on simplification, my sum is equal to 64 by 27 minus 4 by 3. So multiplying by 9 divided by 1 by 3. That's equal to 64 minus 36 divided by 27 divided by 1 by 3. 27 gets cancelled. It's 9 times. So the top one, 14 minus 6 is 8 and 5 minus 3 is 2. 28 by 9. That my sum. So my product is alpha squared by beta into beta squared by alpha. Gets cancelled. So that is alpha beta, which is nothing but 1 by 3. Now I'm going for my quadratic polynomial. So the quadratic polynomial, you know the standard form. The standard form, when the zeros are given, so my quadratic polynomial is x squared minus sum into x plus the product. That is x squared minus my sum is 28 by 9x plus the product is 1 by 3. As simple as that. I got my quadratic polynomial whose zeros are alpha squared by beta and beta squared by alpha. Next question, find a quadratic polynomial whose zeros are reciprocals of the zeros of the polynomial ax squared plus bx plus c. And we know that p of x given as ax squared plus bx plus c. You cannot find the factors. So I would go with alpha plus beta is equal to minus b by a. Alpha beta is equal to just c by a. Now, what they are telling us, the zeros of the another polynomial are the reciprocals. So alpha and beta are the zeros of this. So I would have my reciprocals as are 1 by alpha and 1 by beta. Now I have to find my sum of the zeros. So S is equal to 1 by alpha plus 1 by beta. Take the LCM divided by alpha beta. So my alpha plus beta is equal to minus b by a into alpha beta is equal to a by c gets cancelled, which is equal to minus b by c. And my product is equal to alpha 1 by alpha into 1 by beta, which is equal to 1 by alpha beta. So that is equal to a by c. I got this also as the product. Now we move on for writing the polynomial. The polynomial takes the form such that x squared, p of x is equal to x squared minus sum into x plus the product. So x squared minus, the sum is minus b by c, so it becomes plus b by c into x, and product is plus a by c. So my quadratic polynomial for the zeros 1 by alpha and 1 by beta is as simple as that.